Hello everyone, my name is Hou-Chang Chen. I'm from Taiwan, the National Zhongxing University, and I'm the master student. Today I would like to talk about machine learning model with GIS for predicting the ecological pattern of Schima superba in Taiwan Huisun experimental forest station. There are 6 sections in my presentation, from introduction to conclusion. At the beginning, the modeling the spatial distribution of biological phenomena has always been an important issue in vegetation science. However, but it's difficult to know the species geographic distribution accurately, since it will always suffer the problem as below: the compressed characteristic in forest, and the compressed environment, and accuracy of location, plus temporal and spatial interaction. Those problems always made modeling the distribution over a big area become a mission impossible in the past time. But now, thanks to the technology innovation in the last few decades, especially in the remote sensing and the geographic information system, they have a gradually enhanced scientific capacity to meet that challenge and give them ability to describe the pattern in natural over spatial scale and at a greater level detail than ever before. So today, I use a new approach, machine learning model, and integrate the 3S technology to modeling the species distribution. Review study before, I have some interesting issue. The first, in the red factor, if we use to build our model, we could find the average species can substitute for the red factor. The red factor such as the temperature, the rainfall, and can partially substitute. That's the kind of the variable. But when we use indirect factor to build a model, the model that type cannot be applied at a broader scale. That means the model only can use exam without a limit error. So that idea inspired me to understand what will happen in prediction model. So I picked out a light-emitting tree species like this Chinese Goga tree. It's widespread in central Taiwan and have excellent fire-resistant characteristic, and one of 5 broadleaf tree species and good for fitment. So I picked out that tree species in our study. So the core of the idea, we apply MaxN and the DT2 model developed from indirect factor to predict the potential habit of single species Chinese Goga tree, CGT, and evaluate the spatial extrapolation ability of 2 models. And next, we could see the study area. We chose the study area with rectangle shape, which encompasses the Huisun forest station. The total area is 17,136 hectares, and the elevation ranges from 454 to 2490 meters. And Huisun forest station is the representative in Taiwan, in central Taiwan, and it's full of the plants. Now, I want to talk about the flow chart, and next celebrate 4 sections, from data collection to data processing. And we overlay 5 environments, including elevation, slope, accept, terrain position, and the vegetation index from 2 spot 5 image to generate it. And we can overlay the layers into the GIS database. And then the Chinese Goga tree sample obtained by a GPS were collected by using post-process differential collection. And in situ data were from the Dongfeng and the Guandao watershed. And in order to test different sampling design, we create 3 sampling design. First, we use 2/3 of the Dongfeng sample used as training data for base model development, and the remaining 1/3 of Dongfeng sample were used as test data for model validation. At the beginning we used only Dongfeng data. And the second, SD2, we also use to compare the performance the model built from SD1. So we also use the same data to build our model, but we taken from another place across to Guangdao watershed and far from 5 kilometers to test the model. How about the model performance? And to want to evaluate the model if only grow from the Dongfeng's data can be across to another place. So that's ideas we want to know. And the third one, the Dongfeng and the Guangdao sample were merged into one data set and celebrate two subsets. And two-thirds of the merged one data set were used as training data for model building, and the remaining one-third of the merged data were used as test data for model validation. That's the SD3 idea. And so, integrate this data, we could input our two prediction models to calculate the parameter. The first one, the maximum entropy, is a new promising model. His idea is using entropy principle. We set a model will satisfy the given constraint, and among those there will be one with the large entropy, and which, according to maximum principle, should be chosen the optimal, and we are approaching our real condition. So that's the idea is very good. And the second, the decision tree model, is a common and famous model. We input our data to root node, and it will split the data and has as homeless as possible. And splitting is continued until the limit of any criteria has been reached. And then the terminal nodes are assigned a final outcome based on the group membership of majority of cases. So finally, it's really important to know the model performance. So we use the text-free sample validation approach to assess classification accuracy and implementation efficiency, and compare spatial extrapolation ability of two models. And that table summarized the maximum and DT, the model result. We could see as showing SD1. Two models have a good performance in SD1 and keeping a high ability in prediction. We could see the overall at 92% and 93% kappa is very good. But when we use independent sample far from the Guangdao the sample to test extrapolation, we could easily find the overall accuracy significant decrease, and even kappa value become a 0. That means our model cannot be crossed another place to predict. So it's not good for our model. So that in Things Lab, we use SD3 to add another place Guangdao sample in training data to build our model. And we can, how about the result will be? And the result gives me a surprise answer. We could easily find the SD3, the overall accuracy lift back to acceptable level, and the kappa value also show that the lift back. And we further use the producer and the user's accuracy. We could see, as showing you D1, we could easily know not only have a good classification in the background modeling, but also the happy prediction also have not bad results. But when we use a text from the Guangdao watershed, the sample, we could see the produce and the users, the accuracy is significant decrease. And I further to show you the map of Chinese Gogga tree potential happy. The green is our modeling the background tree, and the yellow is our potential possible site place. And we could find that at first stage, two models can reduce the survey less to approach 6%. Show our to have a good classification. And then we could to compare to SD1 and SD2. We could see when we in Dongfeng sample, we could find they have a good, not bad prediction. But when we extending to SD2, to Guangdao watershed, they are totally wrong and have happened a serious problem. That means we don't we use the topographic variable to build model cannot be crossed another place to predict other place. And DD have a similar case with MaxN. You also have a good performance within Dongfeng watershed. But when we extend into other places, we use independent sample to test is not good because it's easy to find. So since that we use SD3 to add another place sample in training data to build a model, we could find the users and producers accuracies and lead back to a set level. Further to compare SD2 and SD3, we can easily know maximum in SD3 have been proved in Guangdao watershed, and the decision tree also have been proved like maximum. Also, other places have been proved there. And above results, I draw the two conclusions. First, according to accuracy, as shown in the SD1, both overall accuracy and kappa value with decision tree were somewhat better than the maximum. And two models gradually reduced the area of field survey to fewer than 6% of entire study area. It was better for predicting the potential habit of Chinese Goga tree because the savvy much in both cost and level. And then the process of building and validating model is very fast, but it needs to switch over different soft platform. That means it cannot all in one in process, so we need to always switch different soft platform. And second, at the prediction different spatial scale, we could see two models have a good performance, overall accuracy, and the kappa value since both models were developed only from the Dongfeng sample set. But when we extend into other places, like SD2, predict accuracy declines sharply. Maximum and both maximum and DT have a significant decrease, kappa value even the 0. While SD3 predictive accuracy leads back to a acceptable level. And so we could find the idea the topographic attribute of the Dongfeng are quite different other places. And the model merely based on the topographic variable could not be applied to predict the species distribution at a large spatial scale. That's our today's the study area idea. We only use the Dongfeng sample to build model, cannot to predict other places. So we still lost key factor for predict model, such as data quality, like accuracy or resolution of data, and the direct predictor, like rainfall and the sunlight or the temperature or soil, will not take into consideration. So future study will also attempt use high spatial resolution and hyperspatial image to data for building model. Thank you for your attention.
Thank you very much. So, do you have a question, comment? So you mentioned you have to make a model, different model for region to region, region by region.
Yes.
Does it mean it is impossible to make a global universal model?
Yes, we want to use a local place and to predict and extend into other places possible aside, and we also to other places to take the sample to want to evaluate and or prove next place can our model performance good.
Yes. You used spot 5 data for the analysis.
Spot 5
If you used another low resolution data such as MODIS, I think you can cover more wide area by one model.
MODIS not a spot 5 image. The resolution is at 10 to 10 meters, and MODIS is not good for spot 5 image. So we future want to try to use high spatial resolution and want to classify in Taiwan forest. Since Taiwan forest is very complex, and even though the topography very complex, so it's hard to we want as forest we want to cross that forest very I don't know how to say. And maybe we could use we want to know the species, the potential happy. Yeah, so try to single, by case. Yes.
Thank you. Do you have question, comment? Okay.
Total sample size 120 individuals.
Sorry, can you use
The total sample size is 120 individual trees, right?
total sample size?
The
Yes.
tree individual.
Yes.
It's hard to increase the sample size.
It's hard. It means it's hard to.
Yeah, I think if you want to promote the accuracy of your model, maybe the sample size is important.
Yes,
And
true.
when you collect the sample, I think the easiest way to collect sample is by trail
Yeah.
or roadside. That means your sample will plant in small areas, so that will restrict your model accuracy.
Okay, thank you for comment. And first, I have two ideas. First, we know the sample size is very important, but it's hard to survey totally. When we said tally means totally to survey every tree species by using a GPS. Since Taiwan is the topography is very compressed, so it's hard to go to in situ data everywhere. So we try to use the limit, the local place to log that data tree species, and try to extending other places to predict. And the second, our team not very strong, so we still cannot to go to everywhere by correct every sample. And as the statistic and as the society statistic, one variable need to 4 sample, and so I'll have 5 variable. So 20 sample can I guess can enough to our prediction model. Maybe we still try to know to get more and to collect more sample and try to want to improve our prediction model. Thank you.
Any other question? Okay. So,
Okay.
Maybe you can try the Hungarian collect Hungarian's records.
Records.
The collection from the Hungarian,
Yes.
so you can check the records from Taiwan's Hungarian, for example, Taiwan universities and Taiwan Forestry Research Institute.
Thank you, Kang.
thank you, Dr. Chen. So let's move on to the next speaker. I'd like to invite